Welcome back to General Chemistry mini lecture series, lecture 16, Solutions and Concentration. First, let's take care of a few terminologies: solute, solvent, and solution. What is a solution? If you still recall the homogeneous mixtures we learned in previous lectures, so a homogeneous mixture is a solution. If we dissolve sugar in water, make sure all of those crystals, sugar crystals, are dissolved, then we just have one liquid phase. But in that liquid phase, there are two substances still. And then that liquid phase or homogeneous mixture, that is solution. What is a solute? In this example, the solute is what is getting dissolved. Sugar is dissolved. Sugar crystals, that's solid. And after dissolved, the phase change to liquid. So therefore, the component of the solution that gets dissolved is called the solute. And then the one that takes care of dissolution of the solute, that's called solvent. And in this example, water is the solvent. So water dissolves the sugar crystals, and water stays in the liquid state. So that's why in this case, water is a solvent. But sometimes both solvent and solute, they are in the same state. If that's the case, the major component is the solvent. How to make solutions? Here is an example of preparing 1 liter of a 4 molar potassium chloride solution. We use this volumetric flask, and here is the mark, which means when you add solvent till this mark, that's exactly 1 liter. Okay. Of course, preparing this solution, the solvent is water, and then the solute is a potassium chloride. Potassium chloride is a crystal, so we weigh out 4 moles of potassium chloride. So we place the 4 moles of potassium chloride into this volumetric flask. Then we just simply add water to it till this mark. Then you shake it or mix the solution, then that is a 4 molar potassium chloride solution, and the volume is 1 liter. So that's how we normally make solutions. Of course, whenever you have a solution, we have to address the concentration. And molarity is the most often used concentration unit in chemistry. Molarity is defined as the number of moles of solute in 1 liter of solution. Solution means that's for both solute and solvent, all right? Or we can say mole over L or mole over V, V for volume. So that's molarity. Whenever you see this capitalized M, that really means moles of solute and liter of solution. That's it. Let's work on one example. The normal blood glucose level for non-diabetics should be between 3.9 times 10 to negative 3 and 7.1 times 10 to negative 3 molar. Moles per liter. Moles per liter. That's molarity. And we can call that molar. a lab technician found 18.02 milligrams of glucose in 10 milliliter of a blood sample. Calculate the glucose molar concentration. Is the person provided the blood sample diabetic? Okay, of course, in order to answer this question, whether the person is diabetic or not, we have to first find out the molarity of the blood sample. Molarity can be calculated using moles of solute. Okay, moles of solute, what do we know? We have 18.02 milligrams. We start from what is given. And first, we need to convert from milligrams to grams so that we can use the mole concept. And then, you see the milligrams, they are cancelled. Then from grams to moles, using the molar mass. The molar mass for glucose is 180.2 grams. Now grams are cancelled. We should just have mole as the unit for the numerator, the one on top. Then on bottom, we need liters. But what is given here is in milliliter. So therefore, first we need to convert from milliliter to liters. Okay? And now, of course, we have moles on top and we have liters on bottom. Then the answer for this question is 1 times 10 to the negative 2 moles per liter. Okay? So in order to answer again the last question right here, we have to be able to compare this molarity with the range right here. And since here is 10 to the negative 3, and here we have 10 to the negative 2, in order to compare, let's just change this one to 10 to the negative 3 as well. So if we want to decrease the exponent by 1, we have to, of course, move the decimal point to the right once. Then that will be 10 to, that will be 10 times 10 to negative 3 molar. And that's actually is higher than the higher end of the range. So therefore, this person, the person who provided the blood sample, should be considered as diabetic. Okay, let's keep working on molarity. So in C, you see in the key equation, so you need to remember this key equation, molarity equals moles over liter. But moles of what? Moles of solute, liters of solution. But from this key equation, you should be able to obtain related equations. For example, if we know both molarity and volume, we should be able to calculate the number of moles. So then moles equals molarity times liters, all right? So basically we move the liter to the other side, so from denominator to numerator. So that's M times L. That's exactly what we have here. Then another related equation, we should be able to calculate the volume if we know the molarity and moles. So therefore the liter equals molarity divided by mole. So therefore a good strategy is just memorize this key equation, but be able to develop related equations for calculating mole like this one, or calculating the volume like this one. Here is one example. A 2-liter sucrose solution has a concentration of 0.5 molar. How many grams of sucrose, here's the molar mass, are contained in this solution? Okay, so let's take a look. What are given? Molarity is given, M, and then The volume is given, so liter is given. All right? And what do we need to find out? We need to find out the number of moles. Okay, we know molarity, we know liters, then the number of moles can be calculated by simply multiplying M by L, which means molarity times the liters. So we can find out the moles. That's the first step. The second step, we can convert from moles to grams using molar mass. So those are the plans. Okay, first find out the number of moles. We start from molarity and then multiply by the volume, that's 2 liters. Then we have 1 mole. Okay, the number of moles is 1. And now we convert from moles to molarity to grams, from moles to grams. Then we have to place mole on the bottom and then grams on top. That should give us 342 grams of sucrose. Now let's take a look at the second example. What volume in milliliter of 0.225 molar sodium nitrate is required to provide 20.55 grams of sodium nitrate? Okay, what do we know? We do know molarity. All right, so the molarity is given. And then we do know the mass. Mass is given. But from mass, we should be able to find out the moles. So therefore, we do know molarity and moles. If we know molarity and moles, we should be able to calculate liters. All right? So once we know liters, we can further convert liters to milliliters. So this is the strategy for solving this problem. Okay, let's find out the moles first. So we know grams using the molar mass. Then we found out the number of moles for sodium nitrate. From number of moles, which is 0.2418, divided by the molarity. So molarity is 0.225 moles per liter. You can see moles and moles are cancelled. Then the unit for the final answer should be liters. That's 1.07 liters. So we can convert that further, of course, to milliliters, since milliliters is asked. So therefore 1.07 times 10 to the third milliliters. That's the answer for this question. Now let's talk about the common concentration units. We already learned molarity. Sometimes we need to work with much lower concentrations. So therefore we can also use millimolar as the concentration unit. So that equals millimoles over liter, and that's actually 1,000 molar. Micromolar is the number of micromoles in 1 liter of solution, and that's 10 to negative 6 molar. Okay. How about other concentration units? There is one that is called molarity. Not molarity anymore, it's molarity. So we use a lowercase m for molarity. That equals moles of solute over kilograms of solvent. Okay. Then we have a series of other concentration units. For example, percent m over V. That equals the mass of solute over the volume of solution times 100%. And as you can see in the pharmaceutical industry, so many drugs, they use the first 3 units allowed. And in environmental analysis, we use PPT, PPM, PPB allowed to describe the concentration of trace amount of chemicals. Let's work on one example. What volume of solution is needed to prepare 1% M over V sodium chloride solution using 15 grams sodium chloride? Let's take a look. What are given? M over V percentage, that's given. Also, mass is given. Okay, so we have M over V, and we know mass of solute. We just need to find out the volume of solution. The volume of solution, yeah, so the V can be calculated using the mass of solute, then divided by the percent of M over V. All right, so basically, from this equation, this one is known, this one is known. We just need to switch the positions of these two. Therefore, we can get V equals mass of solute over percent M over V times 100. Okay, the mass is 15 grams, the percent is 1 times 100. So then we got 1500 milliliters. So that's the volume needed to prepare this solution. Now let's go over dilutions. So first, let's look at concentrated solutions, which means solutions with a very, very high concentration. We normally call that stock solutions. Then there are also the so-called dilute solutions. And then, of course, the concentration of those dilute solutions are much, much lower. So here's the molarity definition or equation. From that key equation, we should be able to calculate the mole. You see the mole equals molarity times liters, ml. Since liter is volume, that's why sometimes you will see mv. So that's the same thing, all right? So that's a number of moles. Then when you dilute a concentrated solution, then the number of moles of solute before the dilution should be the same as the number of moles after the dilution. So that would make sense, all right? So therefore, M1V1, what is M times V? That's the moles, okay? M1V1, M1V1, or M times V. M1V1, that's M times V. What is it? It's mole. So therefore, the moles before dilution equals the mole after the dilution. Okay. And here, M is molarity, but if you use this specific equation, the concentration, you don't necessarily to always use molarity. So you can use any other concentration. That should be fine. That's why we can also write C1V1 equals C2V2. Okay, but let's stay with molarity. From this one key equation, you should be able to develop other 4 related equations. For example, if you know everything else but M1, then you should be able to calculate M1 using this equation. You see M1 equals M2 V2 over, we move V1 to the other side as a denominator, over V1. You can do the same for V1, for M2, and for V2. Let's work on one problem. What volume of 1.030 molar iron 3 nitrate must be diluted with water to prepare 500 milliliters of a 0.5150 molar solution? Okay, so we are going to use this key equation. And now we know three quantities. All right, we know 2 molarity before and after the dilution. Then we know the volume after the dilution. All right, which means we also know V2. So therefore we know M1, M2, we also know V2. We just simply need to calculate V1. Okay, if we need to calculate V1, we just move M1 to the other side as a denominator. So therefore V1 equals M2 V2 over M1. Okay, now V1 equals M2, that's 0.5150 molar, that's after the dilution, then multiply by the volume after the dilution, V2, all right, that's 500 milliliters, then divided by M1, the stock solution before the dilution, that's 1.030 molar. Then we have 250 milliliters. That's the answer for this question. Let's work on another one. If 150 milliliter of water is added to 50 milliliter of a 6 molar hydrochloric solution, what is the molarity of the diluted hydrochloric solution? So what do we know? We know the volume and the molarity before the dilution, and we also know the volume after the dilution. So we just need to find out the molarity after the dilution. We need to find out the M2. So if we need to find out the M2, we just move V2 to the other side as a denominator. So therefore, we have this equation. M2 equals M1 6 molar times V1 50 milliliters over V2. What is V2? V2 is not just 150 milliliters. It is the sum of 150 and 50 milliliters. So make sure you don't make any mistake here. Then we have 1.5 molar. That's the answer for the second example here. Here is quiz number 1 for end of lecture 16 quizzes. The calcium concentration in a river sample is 115 milligrams per milliliter. What is this concentration in molarity? So we know the key equation for molarity is M equals mole of solute over liter of solution. So now what do we know? We do know the mass in 1 liter. So therefore, first we need to convert from milligrams to grams, and then from grams to moles, then we can apply this equation. All right, so let's do it. I'm going to continue with this equation right here. Okay, so I'll place liter on bottom, and then on top should be 115 milligrams. 115 milligrams, converting from milligrams, 2 grams. So 1 gram equals 1000 milligrams, and then convert from grams to moles. For calcium, the molar mass of calcium, take a copy of periodic table, that's 40.08, 40.08 grams in 1 mole. Okay, so now let's take a look. We can cancel the milligrams and also cancel the grams. So now you see we have number of moles on top. That's just like here. Just like here. M equals mole. So on top we have mole. Then on bottom we just copy that liter given in the question. Alright? So and then you just work with your calculator. Then you should be able to get an answer of 2.87 times 10 to negative 3 molar. Then B is the correct answer for this question. Now you can work on the remaining quiz questions and also homework assignments. This is lecture 16. I will see you guys in lecture 17.